Hello and welcome to Math with Mr. P. Today we are going to be doing 7th grade math. This is Chapter 3, Lesson 1. Now, for my students that were in last year's class for 6th grade, there's going to be a lot of review in this chapter. We're going to be going over integers, both negative and positive integers, how to graph, and what absolute value is. Now, before we start the lessons for this chapter, again, this may be familiar to all of you, but this is what they want us to do. They want us to review. So these lessons may be a little easy. This chapter might be a little easy, but bear with me. And these videos may be a little shorter than what we're used to. So the first thing we're going to deal with are integers. An integer is any number from the set of negative and positive whole numbers and 0. An integer can be a negative, a positive, or 0. Again, whole numbers. So numbers like 5 and negative 8 are called integers. So under the describe it, we would put something like any whole numbers, both positive and negative, and 0. I'll list some examples. Again, examples of integers could be negative 5, negative 7, negative 13, 0, and positive 1, 5, 11, 27, etc. Integers will not have decimals. This is not an integer. So again, all whole numbers, positive and negative, and 0 are integers. And that covers also negative and positive integers. On a number line, you will have negative numbers to the left, positive numbers to the right. And remember that 0 is the absence of negative and positive. It's nothing. It can't be negative and it cannot be positive. It's nothing. But 0 is also an integer. The bottom of a snowboarding half pipe is 5 meters below the top. Circle the integer that you would use to represent this option. So as we talked about in class, there are certain words that will tell us direction. The word here is below, which means it's negative 5. Describe another situation that uses a negative integer. Using the word below, for example, like sea level. Let's say the wreckage is 100 feet below sea level. This would indicate a negative integer, negative 100. It's below sea level. Whereas if a mountain is above sea level, say, 3 miles above sea level, this would indicate a positive 3. Whereas the level of the sea would be 0. Identify and graph integers. So as we talked about, negative integers are going to be written towards the left and will always have the negative sign in front of them. 0 is the neither positive nor negative. And positive integers are going to be on the right side and typically written with a positive sign. Integers can be graphed on a number line. To graph an integer on the number line, draw a dot on the line location. And to take it one step further, this is a horizontal number line, and we've talked about vertical number lines, or a gigantic graph with quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4, which we talked about last year. Positives are to the right and up. Negatives are to the left and down. In the example we just gave you with sea level, we were using a vertical number line. Write an integer for each situation. An average temperature of 5 degrees below normal. This would be negative 5 because it is below normal. If it's 5 degrees higher than normal, it would be positive 5. An average rainfall of 5 inches above normal would be represented by the integer positive 5 or just 5. This means that there's 5 inches more of rainfall than they are used to. An integer for each situation, 6 degrees above normal, above would indicate a positive 6. 2 inches below normal would indicate negative 2. Graph the integers positive 4, negative 6, and 0 on the number line. Now let's see if we can get a highlighter here. There we go. So positive 4 is going to be on the right of 0, and luckily 0 is one of the numbers they want us to graph. So there's 0 and positive 4, and negative 6 will be to the left of 0 right here. Pretty straightforward. Got it. Graph each set of integers on a number line. So here they want us to graph negative 2, 8, and negative 7. So we're going to go ahead and do this on our digital whiteboard. Putting 0 in the middle. Negative 2 would be on the left of 0, probably somewhere right here. So I put a dot there for negative 2. Positive 8 would be on the right, and we'll put 8 down this way. And they want a negative 7, which will be probably right around here. Now, if you want to write out all of the numbers in between, be my guest, and so on. But these are where those are going to be graphed on a number line. Utilizing 0 in the middle, they want us to graph the set of negative 4, 10, negative 3, and 7. I'm going to write these over here. Negative 4, 10, negative 3, and positive 7, if I'm not mistaken. So, negative 3 will be right here with negative 4 right after it. Because remember, when we go to the left, we're starting with 1, 2, 3, 4, 5, 6 going this way. The numbers will go in, I don't want to say ascending order based on the numbers we know, but remember, negative 3 is a lower number than negative 1. That means you owe $3 versus owing $1. So it will go in backwards order. It's like looking in a mirror. So negative 3 and negative 4 have been graphed, and this would put 7 over here with 10 somewhere over here. Now, absolute value. We've talked about this last year. An absolute value is written as such, where a number is written inside of these two lines. Now, if that number is positive, it will remain positive. So the absolute value of 8 is still just 8. Versus the absolute value of negative 8 will be 8. Anytime a negative is inside it, it will turn into a positive. What absolute value means is the distance away from 0. So in this case, we have the absolute value of 5 and the absolute value of negative 5. 5 is 5 units right here. 5 to 5, it's still 5 jumps. On the flip side, while it is negative 5, there are still 5 jumps here. So the absolute value of negative 5 is still 5. It's how far away from 0 it is. Positive 5 is 5 units away. Negative 5 is also 5 units away. So the absolute value of 5 and negative 5 is still just 5. The trick, however, and it doesn't involve this chapter, but in the past, if the negative sign is on the outside of the absolute value, so it's asking for the absolute value of 5 with the negative on the outside, this will still be absolute value of 5 is still 5, but that negative carries over and this becomes negative 5. If that negative symbol is inside, no negative symbol carries over, and the absolute value of negative 5 is 5. So that's the one kind of tricky thing that they do. examples for evaluating each expression. The absolute value of -4 is 4 because it is 4 units away from 0. The absolute value of -5 minus 2. Now this is where we start getting into these little expressions. Absolute value of -5 minus the absolute value of 2. We will rewrite this as 5 minus 2 because this is not inside of a absolute value. The absolute value of -5 is 5. The absolute value of 2 is 2. This becomes 5 minus 2, which will then equal 3, as shown right there. For the goddets, we've got the absolute value of 8, which is just 8. 2 plus the absolute value of -3. This will become 3, which will make it 2 plus 3, which will be 5. And over here, the absolute value of -6, which will become 6, minus 5 will equal 1. And then our final example for this, Nick climbs 30 feet up a rock wall and then climbs 22 feet down to a landing area. The number of feet Nick climbs can be represented using the expression 30, or absolute value of 30, plus the absolute value of -22. Because again, he climbed up a 30-foot rock wall and then climbed down 22 feet to the landing area. They want to know how many feet Nick climbed total. This is an example we used last year, that when you walk to school and you walk back home, you didn't go, you didn't undo your walk. If you walk 5 blocks to school, we'll just label this school because I can't draw a school, and then you walk 5 blocks back home from school, that doesn't undo it. You are still walking 5 blocks to school and 5 blocks back. You have walked 10 blocks total for the day. Going backwards does not undo it. Otherwise, everybody would be putting their car in reverse and taking mileage off of it. It doesn't work that way. So, he has climbed up 30 feet, but then climbed back down 22, and it's labeled as -22 because he walked back down. This is the absolute value of 30 and the absolute value of -22. Even though he walked back 22, he still did 22 feet. The absolute value of 30 will be 30. So the question is the absolute value of 30 plus the absolute value of -22, which will be 52. He did 52 feet of climbing, 30 feet up and 22 feet down. He climbed 52 feet. That's it for this lesson. Again, I know some of this is pretty straightforward. It's pretty simple. Please make sure that you pay attention in class because I'm no longer going to be saying what the questions are on the video in case other teachers use it. I've learned this the hard way where other teachers are using it and then their students feel like, oh, well, he said do these questions. Students, pay attention in class to what questions you will be doing for homework. I will give you those options. And remember, on the OneNote, you have the answers here. Again, you're going to need to show your work, and I understand for a lot of this, even I didn't show my work because it's simple. It's absolute value. So they'll be a little bit more lenient with this one. But again, it's review. So this has been Mr. P, Chapter 3, Lesson 1, 7th grade math. As always, I'll catch you guys on the next one.